A soap film of refractive index 1.34 is illuminated by 600 nanometer light incident at an angle 45 degree. Find the thickness of the film using the condition for dark fringes. Here we have the condition for dark fringes as, that is 2 mu t cos r is equal to n lambda. Here mu is given as 1.34 and lambda is given as 600 into 10 to minus 9 meter, and the angle of incidence, the light is incident, the angle of incidence I is equal to 45 degree, and the thickness of the film using the condition of dark fringes. So here 2 mu is given, t has to be find out, cos r has to be find out, and the value of n is not given, so we are writing it as n is equal to 1. So the condition is, that is cos r we have to find out, but we know that according to Snell's law, sin I by sin r is equal to refractive index of the medium, that is mu. That is, we can write this sin I as, or sin I is given, sin r can be written as sin r is equal to mu sin I by mu, sin I by mu. But we know that sin square theta plus cos square theta is 1. Therefore, sin square r plus cos square r is 1. Therefore, cos square r is equal to 1 minus sin square r, or cos r is equal to, that is 1 sin square r is 1 minus sin square I by mu square, or cos r can be written as cos r is equal to root of 1 minus sin square I by mu square. Then I is 45 degree, this sin square I is, as sin I is 1 by root 2, sin square I is 1 by 2, mu is given as 1.34. Hence the value of this cos r will gives it as 0.849 cos r. Substituting the value of cos r in this equation, we get t is equal to n lambda divided by 2 mu cos r. That is, n is 1 into lambda is 600 into 10 to minus 9 divided by 2 into mu is 1.34, cos r is given as 0.849, and this time it will give a final value as, that is, it is 0.22 micrometer, 0.22 into 10 to minus 6 meter. Then the second problem is, in a Newton's ring system, the radius of curvature of the lower face of the lens is 1 meter. Calculate the diameter of the 10th bright fringe if the wavelength of light used is 59 into 10 to minus 8 meter. That is, here the radius of curvature r is equal to 1 meter. The n is given as 10 the bright fringe, lambda is given as 59 into 10 to minus 8 meter. That is given r n lambda. But we have the condition for the bright fringe in the case of Newton's ring is, for the nth bright fringe, d square n is equal to 4 into 2n minus 1 into r lambda by 2. This is the condition for bright fringe in the case of Newton's ring. For the nth ring, the diameter of the nth ring, d n square is equal to 4 into 2n minus 1 into r lambda by 2. Here n is 10 and the n is 10 and r is 1 and lambda is 59 to 10 to minus 8. So we can find out the wavelength of light, so we can find out the diameter of the 10th bright ring. This is the diameter can be find out. dn can be find out. So we can, according to this equation, dn square is equal to 4 into 2 into, that is d square 10. 2 into n is 10, 10 minus 1, 1 into r is 1, lambda 59 into 10 raised to minus 8, the whole by 2. So this will give 2, that is 2 into 20 minus 1, 90 into 1 into 59 into 10 raised to minus 8. This is the value of d square 10. So we have to find out the diameter of the 10th ring, that is d10. This will give the square root of this 2 into 19 into 59 into 10 raised to minus 8. And finally this value will give, it is somewhat 4.73 into 10 raised to minus 3 meter. This is the value of 10th diameter of the 10th bright fringe, d10. So the next question is, Newton's rings are formed in reflected light by placing a plano convex lens on a glass plate. If the radius of curvature of the lens is 1 meter and the wavelength of sodium light is 5890 Armstrong, calculate the radius of the 7th bright ring from the center. That is, here also we have to find out the diameter, first the radius and then from that diameter, that is n is equal to 7 and lambda is 5890 into 10 raised to minus 10 meter. Radius of curvature is 1 meter. Then the condition for 7th bright ring, d square 7 is equal to 4 into 2 into 7 minus 1 into 1 into lambda is 589 into 90 into 10 raised to minus 10 divided by 2. That is, previous problem we have used d square n is equal to 4 into 2n minus 1 into r lambda by 2. This is the equation for the bright ring. Here diameter, radius has to be find out. D square 7 is given this, that is 4 into 13 into 1, that is into 5890 into 10 raised to minus 10 divided by 2. Therefore, the d7 will be, we are considering the square root of this equation 2 and the square root, and it will give the value of this d7 as 0.003933 something like. But we have to find out the diameter. Therefore, the radius r is equal to, that is d is equal to 2r. Therefore, r is equal to this d by 2. That is, it will give it as 0.00196. Or we can write it as r is equal to 1.96 into 10 raised to minus 3 meter. That is the value of the radius of the 7th bright ring.